Welcome everyone. Today I'm going to talk about the omega theta again, and especially about our stacking system. Now, this is especially useful for silicon carbide manufacturers, as silicon carbide boules are only grown to a few centimeters thickness, but take a very long time to cut. So we've developed a system where you can align several boules very precisely and then glue them to a saw beam and cut up to 12 boules in one go, which since the cutting time is about 1 day, means that you save about 11 days worth of saw time. Now, to do that, we have this system with rings. So we would clamp a boule here into the ring. Now this part has a latch so it can move back and forth a little bit, screw to tighten it all the way. And then when the boule is tight, we go and hang it into the frame like this. Tighten the screws, and when we have a full frame, we can attach the top plate and the saw beam. So I've placed a dummy sample in the ring here, but please imagine that this is a silicon carbide boule, and at this stage it would already have undergone top grinding, and the flat or notch would already have been placed in the sample. We would have made sure that that points to a usable direction before we put the sample in the frame. Now we can tumble it according to the measurements from the omega theta. We give it the target tilt, and the omega theta tells us how far we need to turn these two screws, a little bit like we did in the table alignment, and so we can reach the target tilt. So we'll measure, adjust, measure until we are close enough to where we want to be. After that, we'll put the top plate on here. And then we can mount a sawing beam. So then we secure it with these two clamps, one horizontal and just one in this direction. And now we can measure the orientation of the sawing beam support using our tilt correction laser and adjust it using these two micrometer screws. And the software will tell us how far to turn these in which direction. Once it's flat, we can take it out again, apply the glue, and glue the boules to the sawing beam, usually using some sort of sacrificial support, either ceramic or maybe plastic. Okay, and then we have up to 12 boules glued to our sawing beam in an oriented fashion. We can take these out now once the glue is dry and go to our saw, cut all 12 at once, which is a great savings in time and money, since each cut on silicon carbide can take about a day.